Hello students, welcome to Akshara 8 Foundation. So we are discussing about the rotational mechanics. In that we have completed rotational kinematics, and on the rotational kinematics we are doing the problems there. In the last class we have completed some of the problems, and remaining problems we will see now here today. So 10th question you see. A car is going around a circle of radius R1. So this is a R1 there, not 1R, it is R1 with constant speed. Another is going around a circle of radius R2. It is not 2R, it is, okay, we can write there concentric 2R with constant speed. If the both of them take same time to complete the circles, the ratio of their angular speeds will be, so we should find out the angular speed, ratio of the angular speed. So here let us see here, this is a radius of a circular of one car. Then concentrically here one more car is moving with a radius of double of this one. So this is, if this is the R there, so this one will be the 2R. It is 2R radius. A car is moving in a circular path. The car is moving in a circular path. Then if the car is moving in a circular path, so there here the centripetal force and the frictional force will be equal there. So centripetal force we can write here Fc, and so frictional force here Fs we can add there. Centripetal force here mv square by r we can write mv square by r, that is equals to, we know that the frictional force will be mu s mg there. So now here mass and mass will be cancelled there here. So we will be get here v square is equals to mu s into r into g will be there. And we know that we have the relation between linear velocity and angular velocity, r omega. V is equal to r omega is there. If we substitute here in this equation, we will get here r square omega square, that is equals to, so mu s into r into g will be there. Now this r, one r and this r will be cancelled there. So now we are getting here the relation omega square is equals to, so mu s into r into omega square is equals to mu s into g will get there. Okay. So from this mu s, coefficient of the circular track is constant, means frictional coefficient of the circular track is constant, and g will be the constant there. So if that is a constant there, this angular speed is inversely proportional to, angular speed is inversely proportional to radius, or radius is inversely proportional to 1 by omega square. So now here we can add there r1 by r2 is equals to, we can add here omega 2 by omega 1 whole square we can add, or from this omega 1 by omega 2 is equals to, so here we can add there square root of r2 by r1 we can add there, square root of r2 by r1. So here so r2 by r1 is given now. Then actually this is not 2r, it is r2, and this is a not 1r, it is r1. So let us consider this is r1 and this will be the, here it is not this one, here it is r2. If it is like that, then the ratio of this omega 1 is equals to omega 2, it will be square root of r2 by r1 there. So now the answer is what it is, second option is the answer, second option will be the answer. Yes. Now 14th problem we'll see there here. A ball of mass 200 gram is on one end of a string of length 20 centimeter. It is revolved in a horizontal circle, angular frequency of 6 rpm. The angular velocity is, they're asking there. Okay. So here see this 14th question. 14th one, a ball of mass of 200 grams. So here mass is 200 grams. 200 grams we can add there, convert that into SI units, so it will become 0.2 kg, it is 0.2 kg, and radius is given there here r is equals to 20 centimeters, it is 0.2 meters, convert into meters, it is 0.2 meters, revolved in a horizontal circle angular frequency means here angular velocity is given there. Angular frequency is nothing but this one. Angular velocity RPM, 6 RPM. So we can write here this is our revolution. RPM means revolution per minute there. So we can write here this is in one revolution is nothing but in radian per second we can write that 2 pi by minute means 60. So radian per second will get there here. Radian per second. So we'll get here 6 1 6 10 and here 1 and here is 5 So we'll get how much then here? So pi by 5 radian per second. Radian per second. They're asking that only. The angular velocity will be now therefore omega we got there omega is equals to pi 5 by radian per second. So this is the angular velocity. Angular velocity is now so pi by 5. This is the answer. First one is the answer there. Pi by 5 radian per second. Okay. The 15th question they are asking there angular displacements of the seconds hand of a clock in 45 seconds. Seconds hand of a clock in 45 seconds. In 45 seconds means 3 by 4th of the revolution it will be rotated there. Okay. So now angular speed we can add there 3 by 4th of revolution divided by 3 by 4th of revolution we should take there. Revolution. 3 by 4th of revolution per time. How much time here? 45 seconds. 45 seconds. So they are asking angular displacement only. Angular displacement, not the angular velocity. So we should find out only the angular displacement. So then omega is equals to d theta by dt. Theta by time we can add there. So theta is angular position. Angular position. So it will be 3 by 4th of revolution we can add there. 3 by 4th of revolution in radians. So we can add there here 2 pi. So means 3 by 4 into 2 pi. 3 by 4 into 2 pi. So it will be 6 by 4 will become there. So that we can find out there. Okay. So now see the next problem. So 15th one you see there here. So 15th question, 15th solution, the angular displacement of the seconds hand. See here the second, the watch it is 12 now, and this will be the 3 and 6, it is 9 there. Seconds hand, so it will be initially it is start from here there, so it will be rotated up to here, means this is a 1 by 4th, this will be the 3 by 4th of the revolution, 3 by 4th of the revolution. Okay, 3 by 4th of the revolution. So 3 by 4th of the revolution means this angular displacement. This one they are asking there. What is the angular displacement? So here revolutions theta is equals to, or we can say angular displacement. Angular displacement is equals to 3 by 4th of revolution. 3 by 4th into 1 revolution. So revolution we should convert into radians. So we know that one revolution is equals to what can we write there? 2 pi radians. 2 pi radians. One revolution is equal to 2 pi radians there. One revolution is equal to 2 pi radians. So then here we can add there 3 by 4 into, so 2 pi we can add there. So it will become there, and here 1s and 2s are here. So we will get here 3 pi by 2 radians. 3 pi by 2 radians will get there. Therefore the answer is here. So answer is here. Theta is equals to 3 pi by 2 radians. 3 pi by 2 radians. So this is the angular displacement. 3 pi by 2. So answer is here now. This one. 3 pi by 2 radians. If the length of the seconds hand in stop clock is 3 centimeters, the angular velocity and the linear velocity of the tip. Angular velocity and the linear velocity of the tip. So here in this question it is given their angular radius is given there. Length of the seconds hand, that is the radius, no, 3 centimeters. It is in meters, it will be 0.03 meters. 0.03 meters. Convert that into meters. Now we know that stop clock, angular velocity of a seconds hand. Okay, for whole revolution, so angular velocity denoted by here omega, no. So seconds hand, if it is complete one revolution, it will be complete 1 minute, na. Okay, in the clock, in our clock there. So this is a 12, 3, 6 and 9. Okay, the seconds hand started from here there, and it will be complete one revolution like this, and it will be stops here there 360 degrees. It will be rotated there. So for one rotation, if the seconds are rotated here one rotation, it will complete 1 minute. So then here we can add there one revolution per how much time it will take there? 1 minute, revolution per minute. So revolution per minute is nothing but we can write here in the radians. It is in the radians, one revolution is nothing but 2 pi divided by here minute. Minute means how much here? 60 seconds. So here we can add there pi by 60. So pi by 30 seconds. So this is a pi by. So cancel this one here. So pi by 30. So now calculate that value here. Omega is equals to pi value. We know that it is 3.14 divided by 30. So here it can be written as 0.314 divided by 3. So if you multiply here, if you divide here, 0.1. So here 0 into here we can add there 4, 0.14 will get there 0. So revolutions per second. So 3.14. So here we'll get there angular velocity. Here we can add there this one. So 0.14. Then if you calculate, we'll get here 7. So we'll get here radian per second will get there. So now here we got the angular velocity of the seconds, and it will become here 0.1047 radian per second will get there. Radian per second. So this is the angular velocity, and we should find out here now the linear velocity. So linear velocity formula is what we have learned there. Linear velocity will be here V is equals to R into omega. Okay. So now here R value is given there 0.03 meters. Okay. So now here we'll write there 0.03 into angular, this one angular velocity we got there 0.1047. Now multiply here. If it is multiplied there, so if this has multiplied there, how much we get there? So 21, 12, 13. Okay, and 3 will become here. So then it is 21, 12. Well, here we will get the answer as so the answer is here we will get there 21, 12, 14 will get here 14, 0 here 1 will get there, and it is 3. So after 1, 2, 3, 4, 5, 6, so we will get here already 4 is there here 0. So means 0.00314. So 0.00314. Where it is there? Here. This third one will be the answer there. Okay. So this is a linear velocity, and it is what there? It is in meter per second. So this is a linear velocity, and this will be the angular velocity. So the option is what here? Option 3 is correct. Option 3 is correct. Okay. Note it down. Now in the second question it is asking there the angular displacement of the seconds hand of the clock in one and a half minutes there. 1.5 minute means how many revolutions it will be made there. So for 1 minute it will be complete one revolution, one rotation it completes there, and half rotation, half minute means it will be complete semicircle, means one more half rotation it completes there. Okay. So then 1.5 revolution per second, 1.5 revolution per second. Here 1.5 minutes there. 1.5 minutes means how many seconds? 60 seconds plus 30, 90 seconds. 90 seconds. Okay, so that we can find out there now. So 1.5 revolution. 1.5 revolution means here 2 pi. 2 pi by 1 revolution is 2 pi plus pi. So 2 pi by 2 pi. So we'll get here 2 pi plus pi. 3 pi will get there. 2 pi plus 3 pi by here 90. 3 pi by 90. So that we'll get the answer there. Okay. So there, see the now. So 17th one. The angular displacement of the seconds hand of a clock in 1.5 minute. So they are asking only angular displacement, means angular position we should find out there. So theta is equal to how much there? So seconds hand, if it is rotator, 1.5 revolution, 1.5 minutes. In 1.5 minutes, see, in 1 minute it will complete one full rotation there, 2 pi, and then in half minute it will be complete there, pi, 2 pi by 2, so pi there. So here we can add there. So theta is equals to 3 pi. 3 pi will be the 3 pi radians. 3 pi radian will be the, that is the answer there. For one complete rotation, 1 minute. Okay. For half rotation, it will complete half rotation, it will complete half minute there. Okay. So that we will get here 3 pi by 3 pi radians. 2 pi for one complete rotation, 2 pi there, 2 pi radians. Half rotation, it is the 2 pi by 2, 2 pi by 2, so pi will get there. So then now total displacement it is 2 pi plus 3 pi, it will be 3 pi radians, 3 pi radians. So next problem we will see here. Yes. So in this chapter we have completed this all the problems there. Then we will see their practice sheet. Next practice sheet we will do. So my task is there, no? Here you can solve the problems there. Level 1, level 2 problems are there. Based on these all the formulas what we have discussed there. Based on that it will be there. You try them and solve them. So in the next class we are going to start there synopsis 2 rotational mechanics about the moment of force. That is nothing but torque. Okay. So we will see in the next class about the torque, and we will complete that synopsis also in the next class. Thank you children, have a nice day.